This set of Google Slides is about Chapter 9, Sections 2 and 3. In Section 2, the only thing I want you to know is the term plate tectonics, which you should recall from last year's Earth Science. All you need to know is that the plates are moving. They move rather slowly, but they can be measured over time. In Section 3, we're going to talk about acceleration, which is talking about the change in velocity over a unit of time. We will use the same formula even though there are 3 different types of acceleration. Anytime we say there's acceleration, we're talking a positive number and an increase in speed. Deceleration is also known as negative acceleration, and then you have a negative sign in front of the number. It just means you're slowing down. Circular acceleration means you have changed direction. There may also be a change in speed, or you could also have constant speed going on, but you have a change in direction. Now, to calculate acceleration, the basic formula for this is A, which stands for acceleration, is equal to the final velocity minus the initial velocity. So V of F minus V of I divided by the total time. Okay? So when you have your answer, typically it's going to be meters per second squared, which can also be written as meters per second per second. That's what the squared means. You have 2 units of time that are the same. You could also have miles per hour per minute or miles per hour per second if you're talking about the rate that somebody is drag racing or something like that. Okay, so know that there are 2 units of time and a distance. When we graph acceleration, it may look similar to a speed or velocity graph, that you have time on the x-axis, but instead of distance on the y-axis, it's now the speed. So a linear line, meaning that 45-degree line, is going to be constant acceleration, just like that 45-degree line was constant speed in a velocity graph. A horizontal line this time means constant speed. You're going the same speed over a unit of time. Instead of with that velocity or speed graph, the horizontal line meant you were stopped. Your distance did not change, but your time did. So you have to look at your units on your y and x axes to make sure you know which graph you're looking at, because they can look the same but mean different things. Okay? So let's look at the first practice problem that's in this section. We have a roller coaster that's rapidly picking up speed as it rolls down a slope or hill. As it starts down the slope, its speed is 4 meters per second. 3 seconds later, its speed is 22 meters per second. What is its average acceleration? So this time we would just want to know how fast did it go overall. So your final velocity is 22, so V of F is 22, minus your initial of 4 meters per second, and then you're going to divide that by the total time, 3 seconds. So 18 divided by 3 means it was traveling roughly 6 meters per second squared each second down that hill. Problem 2, we have a car that's advertised that it can accelerate from rest, which means 0, to 90 kilometers per hour in 9 seconds. How quickly is it accelerating? So your final velocity is 90, minus 0, still 90, and then it's 9 seconds, so 90 divided by 9 is 10 kilometers per hour per second. See, this is where we have 2 different units of time, so we have to represent each unit of time separately. Practice problem 3. An eagle accelerates from 15 meters per second to 22 meters per second in 4 seconds. What's the eagle's average acceleration? So V of F is 22 because that's the final, minus 15, the original, and then that gives you a speed of 7 meters per second. Divide that 7 by the total time of 4 seconds, 1.75 meters per second squared. Or remember, you can write it as meters per second per second. All right, the section 2 review questions. So that theory that describes the slow motion of the contents is called plate tectonics. Two reasons we don't notice the movement is really slow, and we're actually moving at the same rate it is, so we're not going to notice it. Question 3, to describe the movement of the plates, you would use centimeters per year or millimeters per year because it's such a small change. And then they gave you some information and you had to figure out how much it moved per day or year. Section 3, the types of acceleration include increasing, decreasing, and rotational, or increasing, negative acceleration, and circular acceleration is the same thing. To find acceleration, it's final velocity minus initial velocity divided by the total time. Question 3 wanted to know if you're changing direction, is the horse accelerating? And the answer is yes, because it's that circular acceleration. Even if you're going constant speed, as long as you change direction, you are changing acceleration. And then the last question is, would it be going at the same rate? The answer is no, the car could have accelerated at a different rate. Just because they gave you two numbers, just like math, you can have different factors and you can figure out a different rate.